Hi everyone, welcome back to our channel. I hope you and your family members are doing good because that is the most important thing, and for rest we are here to talk. So we were following our pattern wise DSA sheet, and in this we were doing stacks topic. Following the stack based design pattern, today we'll do the last question, which is design stack with increment operation. So let's read the problem statement. Here we have to design a stack, and we have to design, write the functionality for push and pop as well. Along with that, there is one extra method which we have to define, which is increment. And whenever this function will be called, we will be given two things, two parameters. First, we'll define how many number of elements from the stack we have to change, and second value, it means that many number of elements needs to be added by this number. So suppose this is 5. So it means in the stack from the bottom line, we have to pick 5 elements and then add 100 to all such elements. Okay. And whenever we have to, this pop function will be called, then after the increment, if that number has been touched, then definitely we have to return that. Okay. Let's see the constraint. It says the number x and k can vary till 1000 from 1. Okay, so suppose this is what we have to design. The very first information says that we have to take the stack for size 3, not more than that. Okay, so what we'll do, we will make a stack of size 3. Okay, and now we have to push 1. Second is push 1. So we'll push 1 here. Okay, now suppose pop comes. Okay, I think after this we have to insert 2. Okay, now push 2. Done. Now we have to pop. Okay, after this pop, so definitely you will return to this number, you will pop and return to, yes, correct. Now after this pop, you have to insert 2 again. So can I say, I can insert here, yes. Now we have to push 3, I'll push 3. Now we have to push 4, but wait, do you think we should be able to push 4 here? Because the size allotted for the stack was only 3 and we are already full with the number of elements. So hence 4 we cannot push. So in our push functionality, definitely before pushing the element 4, we'll check that if the size is already matching with the max size allotted, then that element we will not push in the stack and we'll simply return that. Okay. So what I said, in the push function, we'll get an element for sure and we'll check if the size, which is suppose the max size globally defined, if the max size is equal to size of the stack. Can I say? Yes. So size of stack dot size. If they are equal, then for sure we will not push anything and we will return from then and there, or else we can say what? Stack dot push x, correct? That's it. So this case we have to write inside the push function. Okay, so hence 4 has not been inserted. Now the second one says key change 5 such elements from the bottom and add the value 100 to it. But as you can see, there are only 3 elements and we have been given 5. So for this, in our question it says increment the bottom k elements of the stack by value, and if there are less than k elements in the stack, it means increment all the elements in the stack. Means it says bottom 5 values, but we have only 3 values. It means we have to add 100 to all such numbers. So now 3 will become 103, 2 will become 102, and this will become 101. Very simple. Yes, whenever increment function will be called, okay, we will decide that this 5 is minimum or the size of the stack is minimum. Whatever will be the minimum value, for that length we will run the for loop and we will change the index, like the value of it. Can I say? Yes. Like we'll run the for loop for 3 times. And in stack, obviously, like we will define the stack using integer array. So using indexes, we can go there and add 100 to it. So make it 101, 102 and 103. Although it will take O of n time complexity for sure. But still we can think about it, right? Now, after this, it says below, like bottom 2 element, again add 100 to it. So bottom 2 elements, yes. Now we can decide. So hence, what was the minimum value? This 2 is minimum or stack size is minimum? Definitely 2 is minimum. So we will run the for loop from 0 to this 2, correct? And now we'll add 100 to it. So this will become 201 and this will become 202. 2. Now we have to pop, pop, pop. So first element when we will pop, we will get 103. Second time when we will pop, we will get 202. Third time we will get 201. And if you want to pop another time, definitely you will get -1 because now stack is empty. And that's what in the output you can see, कि when you popped after increment, you popped for 4 times. First you got 103, then 202, then 201 and then -1 because at the end the size was empty. Very simple. That's what you have to design, correct? So do you think we can optimize it somehow? But you know what? I prefer one method here to solve the problem because we are taking stack using an integer array. So for sure, whenever we are going to insert anything, we can take, consider the index. So definitely, if we are considering the index to insert in the stack, so now for this, I would like to take a variable index and I would like to initialize with -1. Why I am doing this now? Because this will make my work very easy. How? See, this index we will initialize with -1, correct? And whenever this push function comes, I will check कि if this index, instead of calculating the size again and again, I will check if this index is already, you know what, this is what, stack.size, correct? So as per zero based indexing, definitely if stack size is 5, index will go till 4. So if my index is already 4, then I am sure my stack is full and I will not allow my elements to go. Similarly for pop condition, if my index is -1, saying there are no such elements, then we will not pop any elements. Why? Because index is -1 means there are no such elements. And now if I have to insert any such element, suppose it's empty, right? So if I will insert 101, so first the index I will do plus plus. So from -1 it will become 0 and now at this point I will insert. Next time again I will do index plus plus. Next time it will become what? 1 and now here I will insert my next element. Okay. Again, the reason I use the index variable to make my work simpler, like instead of calculating the size again and again, I can simply keep a track using my index. Okay, because we were checking the size at every case. In push, when we have to push some elements, first we have to check what if the size is already done, then we cannot push. Simply in pop, if the size is already 0, then we cannot pop. Hence, this index will help me to define the size of the stack without calculating it again and again. So let's write the code for this. So first we will make integer array stack and index variable, okay, and also we want a max size. Why? Because the max size which will be given in custom stack function, that we want to define it globally. Okay. Now inside this we have to write this dot max size. This you can skip also if you already know, is equal to max size, correct? And also the stack we want to define new integer array of size max size. Okay, we have to define the size of the array. And now index we will initialize with -1. Okay, now whenever the push operation comes, first we will check if the index is equal to what? Max size -1, because size will be suppose 5. But if index is 4, then we can say like stack is already full, correct? If it is so, we will not push anything and we will return, correct? Else what we'll do, we have to increment our index, so index plus plus, and then at stack index, correct, we have to insert our x element. Done. Now for pop, what we'll do? For pop, we have to check if our index is equal to -1, means there are no such elements. In that case, we'll simply return -1, correct? Or else we'll store the top value. Like for pop, we have to give, correct? So what we'll do, from stack, we will read the last element with the help of index, correct? It will take just O of 1 time complexity. And now as we have, it's about pop, right? So the top element should be removed, means the index should be decreased. So we will do index minus minus, and now we will return this value, correct? And now in the increment function, we have to define the limit. Why? Because to check what is the minimum value, the k is minimum or else my index but plus 1. Why? Because this k is about size, correct? We have to compare with the size, and index, you know, because of zero based indexing, it's always 1 lesser, so hence we have to add 1 to it, correct? And now we have to run the for loop for int I is equal to 0 to I less than limit, correct, and I plus plus. And now what we have to do, stack of every ith element, we have to increment every element by the value, and done. Now we can run the code. As you can say, it's running, so now we can submit it as well. Submitted. But as you can see, every functionality is taking O of 1 time complexity, but this increment is taking nearly O of n, right? In the worst case, I already showed you. But talking about space complexity, because we are taking this integer array stack, so definitely O of n space complexity as well. That we cannot reduce. Why? Because we have to take some container to store our values, right? So hence space will be O of n. Then can we reduce the increment operation here? Like increment, because it is taking O of n, right? Let's think. See, in the increment, when we already have 1, 2 and 3, correct? And when we have to, change top 5 values, means all 3 values. So what we are doing, we are running this for loop to change every such values. Can I say? Okay. So, but suppose you change every value, correct? But this question does not meant to say that you actually need to change every value. Okay, what I said this function says ki take bottom 5 values and add 100 to all of them. In this case, we have 3 such elements, so basically it means that we have to add 100 to all of them. But what if after this no such pop function comes, correct? Or else suppose one pop function comes, that's it. So it means, suppose the size was 5. It means you are just changing all 5 values, but to check, they only ask one pop function now. Then don't you think instead of changing all such values, whenever the pop function comes, then you can add this 100 value. For that you need to keep a track for sure. But don't you think this will reduce our time complexity? Yes. So basically, I have added 1, 2, 3. Now, idea is when 5 comes now, I will take one more data structure. Exactly. Basically, when you have to decrease the time complexity, your space complexity might get hampered. But not so, because it will still be linear. Like instead of O of n, it will be O of 2n. Okay. So this will be stack, and this you can say as let's say values. Okay. You have stored values here and initialize with 0, 0, 0. Okay. Now here comes ki hey, change bottom 5 values, okay, with 100. So as you know ki bottom 5 values are not there, so minimum value will be 3, which is stack size. So the idea is just change 100 to this place, only one place. That we are keeping a track with the index value variable, remember? So with the help of index variable, whatever the index pointing to, index will point to the top value. So here in this values array, you will go and you will add this 100. Now, when the function comes, for example, pop. So what I will do now, instead of returning the stack value, I will pop this, I will take this, read this, and both of these values I will add it, okay, and now this I will return. But before returning, as you know, this 100 is known to only this index. Previous indexes are not knowing about it. But I am sure about one thing, whenever pop comes, okay, it will only pop the top element, like a single element. So I am sure that when I am going to pop this, add this 100 in 3, so I will just pass this 100 to the below element, not all elements, just one below element. So definitely when we popped, this we can remove, okay, and we will pass this 100 below. So now 3 and 100, so already we have given 103, correct? Now suppose next time 200 changes. Again, see, 2, like change bottom 2 with 100. So again what I will do, my index is pointing to here, I will add 100 more to here. So what I will do, I will change it to 200 now. Now when pop function comes, we will read both of these, we will add it, and I will pass this 200 to the below one and not all the values below. So in this way, we have reduced the time complexity from O of n to O of 1, which is constant, right? So let's write the code for this as well. So here I have already written the code for you all to save our time. First, we will initialize the stack and the values array which I meant here, let's call it increment. Now we will initialize the index as said, which will actually point the top element, and the max size, because which will actually tell us, what is the maximum size of stack allowed. Okay. Now we will define here everything, that. And now whenever we have to push, definitely first we'll check what if the index, see the push function will be as it is, the only difference in the increment and in the pop. Okay. And now in the pop function, definitely first we'll check what if there are no such elements, then to will not pop anything and will return -1. But if we have to pop, then definitely stack top element and increment top element will add it together, and that result we will return. But before returning this index value, we have to give it back to the previous element, but only if that index is positive. Means what if you are popping the last value, then there is no mean to say ki, hey, give this back to my previous element, right? So first we will check if it is positive, definitely to the below element we will add the same value to it. Also, it's very important to change the current value to 0. Otherwise, in future, when suppose 3 gets popped and you will not change the value back to 100. Suppose here was 100, right? So suppose you popped it, okay, and this 100 you have passed below and you have not changed this value. Then what happened now? Suppose next time 4 comes. So for 4, the value should not be 0, right? So when you have to pop this 4 should have been returned, but you will end up returning 100 plus 4, which is not valid. So hence it's very important to change back to 0 this, okay? So that's what we are doing here, and at the end we'll return the result. Definitely it's also taking constant time complexity. Regarding the increment, earlier what we were doing, we were running the for loop for index time. Remember this we named it earlier limit, right? This limit time. So the minimum value we were deciding with k and index plus 1. So earlier we have to run the for loop. So that is why we were running the for loop with the limit as per the size. But here we want a index. This will be the index, as you can see here, right? In limit, correct? So that's why I named it index. So as the IDX is 0 based indexing, so that's why we will check the minimum value, but not with k and index plus 1. No, we'll check with k minus 1 and index because of the 0 based indexing. And now if it is positive, we will just add the value to it. Means here you remember earlier it was 0. So when you have to change the value, instead of changing all, we'll just change the top value with 100, and that's it. So now even increment or pop or push all are taking O of 1, which is far better optimized approach. So now we can submit this code as well. So it's been submitted. So this was the Java code. I hope you understood both the brute force and the optimized approach. The only difference was in the increment idea. Okay. So definitely in the interview, this answer is the expected one. Here is a Python code I have already written for you all. Okay. The same approach. This is the optimized one, means O of 1 pop. Correct? Like constant pop and constant increment. Now here is your code in C++. If you are from C++ background, here is for push, pop and the increment. So I hope you understood both the approaches. If you understood, then you are eligible to go in the sheet and mark the last question from this pattern as done. Congrats everyone if you have covered till now, because we have almost covered 80 to 85% of stack based questions. And if you understood each and every pattern, then definitely you can see the change in yourself. If you are following the playlist, then definitely you can come up with your own logic in the questions. So with this hope that you all have understood, I am expecting a like on this video and definitely a subscription if you have not yet subscribed. And if you guys are new to this channel, we are following the pattern wise sheet. The link I'll definitely add in the description below. And for any kind of guidance, definitely you can reach out to me. I'm very active on Instagram, LinkedIn and Twitter. So with this, let's wind up the session. Let's meet in another video with some more interesting patterns, topics and questions. And then keep learning, take care of yourself and your family.